Greetings. Welcome to Indoor Pool Ventilation, a Fresh Perspective, presented by HPAC Engineering Magazine and sponsored by Innovent, a business of Unison Comfort Technologies. I'm Scott Arnold, Executive Editor of HPAC Engineering. Before we begin, a few words about this webinar technology. This newer platform allows you to be more involved with presentations and, more importantly, allows you to watch events the way you want to watch them. For starters, you can customize your console. You can move windows by dragging on the title bar and resize them by clicking on the lower right corner. On your console, the Innovent logo is hot-linked. If you want to visit the company's website during this webcast, click on the logo and a new window will open. This will not take you out of the webinar. At the bottom of your console, you will notice a toolbar. The buttons there allow you to open and close widgets on your screen. This webinar will conclude with a live question and answer session. You can submit a question at any time during the event. To do so, simply type it into the Q&A box and then click the Submit button. You can download a copy of the slides by clicking on the PDF icons in the resource list. We appreciate your feedback. Please click the survey icon at the left of the toolbar and take a moment to complete the form. If, during the presentation, you experience technical difficulties, such as problems with the audio or the advancing of slides, please refresh your webinar console by pressing the F5 key on your keyboard. Lastly, this presentation is being recorded and will be available for viewing on demand at hpac.com for 1 year. Now, let's meet our presenter. The Vice President of Applications Engineering for Unison Comfort Technologies, which includes Innovent, manufacturer of custom air handling equipment, Carrie Lochner has provided more than 1,000 air handling units for indoor aquatic facilities ranging from high school pools to community recreation centers to major water parks over the last nearly 25 years. Additionally, he has spoken on design considerations for indoor aquatic facilities at ASHRAE chapter meetings. He holds a mechanical engineering degree with heat transfer emphasis from the University of Minnesota. Ladies and gentlemen, Mr. Gary Lochner.
Thank you, Scott, and thank you everyone for joining me today. I'd like to spend some time talking to you about one of the more interesting applications in HVAC, the indoor swimming pool or natatorium. I'll talk a little bit about some of those unique challenges to kind of set the stage, and then bring you into the perspective that Innovent has come at the market with, specifically talking about the effects of fresh air on the application. We'll go into a little bit about what it does to the pool space, and then talk about some common methods for dehumidification and how those methods are affected by using fresh air, and then talk a little bit more about maybe how much fresh air is used well in the indoor pool application. So how are the indoor pool spaces different when you're looking at this versus maybe a typical application? To get it to open, we have a few poll questions during the webinar, and this is the first one. When it comes to indoor pools, what factor do you think is the most important in the design? Is it to create a healthy environment for the pool patrons and workers? Is it the energy costs? Reliability and maintenance, and I would like to know what you consider to be most important of those three. So if you would please submit your answers. So very heavily, it looks like the healthy environment is considered to be of primary importance. And then if you would also go ahead and indicate what your role would be or interest in indoor pools, and submit that. Okay, so we're very heavily right now on designers. Thanks for that information. We have a few more poll questions that we'll be doing during the webinar. So when you're doing some of the unique things in pools with space construction are that the dew point in the space is higher than a typical space, and so you need to be concerned about condensation. The air, because of the pool chemicals, is corrosive to steel, so the material choices are important. You absolutely have to have a good vapor barrier, or you can force the moisture from the pool through your building materials and ruin your enclosure. Pools typically have pretty high ceilings, and so you have some mixing requirements at higher levels to prevent stratification and dead spots. And then there are really within that big space several microzones for the lap and leisure hot tub pools themselves. If you have spectators, that's another spot. You're going to have people on the deck that you need to take care of to make a healthy spot. And then oftentimes you're also going to have a lot of windows to make them architecturally appealing, and with the previous things about dew point and such, that they can be pretty challenging. So those are usually a little bit unique to this application. So I mentioned the high dew point. Well, space temperatures in a natatorium are usually 82 for a competition pool-ish to 86 oftentimes for a rec pool. So you're 10 degrees warmer than what you're doing with a normal space, and that's because the occupants in large part just have swimsuits on, so they need to be kept warm. It results in a heating season that's typically 3 months longer than people think about when they're designing spaces. So a pool application is largely in heating 9 to 10 months out of the year, almost in any climate. So that's definitely one unique thing that affects this application. Another is the dew point or the humidity. You're really trying to keep, like you said, unclothed people really comfortable, and so a lot of times you're in the 60% RH range with that 82 to 86 degree air. So your dew points are 66 to 70 degrees instead of 55 to 60. Water is continually evaporating from the pool, so you have a pool in the space that's different, and it's constantly putting a latent load out there, and that creates significant dehumidification and water heating loads. And then your evaporation, that increases with features, rec features, and activity in the pool. Because of the chemicals that treat the pool water and keep it healthy, they migrate out, and you have corrosion. The humidity, uncontrolled humidity, is going to drive aggressive corrosion as well as the chemicals. So if you keep the humidity under control, 60% or below all year, you're going to increase the life of your facility. And if you do not do that, you can very much create big problems for corrosion and growth of organisms that you don't want to grow. I mentioned the chemicals. So the pools are treated with chemicals to kill bacteria and biological waste, chlorine being the most common one because it's the most cost-effective to deliver and the most effective. Saline pools, if you've heard of those, are really just another way to deliver chlorine. So chlorine is definitely most commonly used, and you have byproducts of that disinfection process, chloramine gases. Chloramines are an irritant to the eyes. They're an irritant to respiratory systems. If you've heard of lifeguard lung or a swimmer's cough, usually that's what is causing that, what people are referring to. They can create a very unhealthy space. And as I mentioned, the corrosion from humidity, well, they're also very corrosive to steel. And to make it even a little more challenging, if you don't get those chloramines away through good air distribution, they'll concentrate right above the pool surface, basically right where swimmers breathe. When that happens, pool chemicals are less effective at disinfecting the water. There's a reference there from the Center for Disease Control, basically making that statement that if the air surrounding the water is full of chloramines, it stops some of the process of off-gassing. They'll build up further in the water and cause more bad health effects for the swimmers. So some of the issues that have arisen since about the mid-'80s, when outside air was kind of limited due to energy embargo, was that the buildings were rotting out and had structural problems. You had the sick swimmers and lifeguards. Objectionable odors. If you smell the pool in the hotel lobby, that can tell you, A, that you've got a lot of chloramines out there, and B, that your water chemistry is out of control. And B, the systems that were there were fairly complicated to operate. There was a lot of mechanical failures. And this is really, when we entered the market, in the mid-90s, those were issues that were happening. And when we started looking at it, our perspective was, well, where's the fresh air in this application? If I looked at equipment schedules back then, oftentimes outside air wasn't even listed. If outside air was listed, the temperatures associated with the outside air and the humidity weren't listed. And the catalog data for a lot of the units that were being done didn't include outside air. And so from a company, Innovent, that did a lot of energy recovery and fresh air, we looked at that and said, well, where is that in the application? And then since we heard a lot about equipment failures, well, why is that equipment so mechanically complex? A lot of times doing a complex solution to a relatively complex application is challenging. And so then also considering the problems that I mentioned, why would you not design an efficient system that really embraced fresh air? So those are the things that we were looking at when we got into the market. And so when you looked at those design challenges, we were looking at it going, well, okay, you need to control the humidity all the time to reduce the corrosion. You certainly want to promote a healthy space. We saw that from the poll question, that a lot of you think the same way. You'd like to control the space pressure if you can to keep the humidity and chloramines from migrating into other spots. You prefer to be able to help the water chemistry rather than make its job harder. And you'd like to be able to design for a more simple system if possible. So those were some of the things that we were looking at when we got into the market. So I've talked a little bit about outside air, and I'd like to briefly talk about, what does the outside air do to an indoor pool space? What happens to the humidity, energy, and chloramine removal? So if we set up a spectrum and said, well, at one end you got no outside air, and at the other end you got 100%, what would that do? And well, if you have 0% outside air, then you obviously need mechanical dehumidification or some form of other dehumidification because you have nothing happening from outside air. You would have no ventilation costs in that regard because you have no load. So you could recover a lot of the energy you use for dehumidification and heat cool water and heat air with it because you don't have any ventilation costs there. So it'd be a very good energy efficient machine, would do a very poor job, actually non-existent job of removing any chloramine from the space. On the flip side, at 100% fresh air, the humidity would fluctuate in a very wide range, very, very low in winter and above set point on humid days in summer in almost all climates except the mountain regions. Because the outside air is going to have a pretty major effect on what goes on. Your ventilation costs would be very high, and also your water heating costs would get quite high because you would drive the humidity down so low during the winter time that the evaporation rate would increase actually by over 100% if you run it that way. Chloramine removal, on the other hand, would be excellent. You would have people thinking that space felt very fresh. So let's talk a little bit about the dehumidification methods that are out there, the most common ones. And that will bring us quickly also to our next poll question. What would you consider the expected useful life of a pool dehumidification unit to be? We've given you some ranges here in 4-year buckets, so please submit your answer. So 8 to 12 years, followed by 12 to 16. And by the way, I would tell you that that meets with the experience of projects we see that have been in and are looking for a retrofit, on average anyway. And then I guess the next question is, what have you experienced the useful life of a dehumidification unit to be? So maybe differentiated from the previous question, if you have different experience from what your expectation might have been. Okay, so unsure, or in this case, expectations maybe meeting what people were thinking, or experiencing what people were expecting. I'd like to talk about some methods of dehumidification, and I did put a little note on the bottom that's important. It doesn't matter what dehumidification method you use, it's not a substitute for having effective water treatment and having effective air distribution. Those are very important regardless of the method that you use. Typically, I've seen they fall into two camps. Either you're using mechanical refrigeration for your dehumidification, or you're doing dehumidification through the dry outside air. Mechanical dehumidifiers have been the most common solution, I would say, since the 80s. They dehumidify return air with a refrigeration system and then recover the energy to offset the cooling that they did, plus heat some pool water. They range from relatively complex systems, some using an exhaust air heat pump and some not, to actually even more complex systems where you might overlay a glycol system on the refrigeration system, or you might have a few different evaporators and condensers and combine things. But in any case, relatively complex refrigeration systems. The operation of the simple version looks this way. You bring the return air back. You can exhaust some air right at the unit on larger systems. Smaller ones might use a separate exhaust fan. You dehumidify the remaining return air, and then after that's done, you introduce a small amount of outside air, typically the ASHRAE suggested minimum, and then reheat it and go to the space. Then you can reject the heat from the dehumidification process to heat pool water, because the evaporation load from the pool creates a little over 1,000 BTUs per pound that you need to handle. So most of the pool water heat comes from evaporation, and you can take that and put it back. You have to typically heat the air back up in those modes, and unless you're in a space cooling in the middle, high season in summer, or you can send it to the remote condenser. On the plus side, the real plus is that you can heat some pool water with a mechanical dehumidifier. And when you look at energy loads, we're not going to talk about it greatly, but it's one of the four relatively significant components of energy, along with air distribution and fans, dehumidification, and ventilation, but air heating. In some configurations, you can use a heat pump to provide some space heat with these systems as well. On the downside, they are relatively complex and are prone to failures. They have multiple condensers on each evaporator, so you have a refrigeration system that typically has 3 condensers operating on one evaporator, and that is a challenge on refrigeration. The control systems for them are also quite complex to control whether to heat water, to heat air, where to send the refrigeration. They don't have a lot of flexibility. If you undersized one, you're kind of stuck. You've got a 40-ton unit, it's going to do 40 tons, and if it happens that your evaporation rate is wrong, you're going to be in trouble. And also then if they change conditions with the water a little bit, it'll be a challenge, and they don't really have an ability to increase the amount of fresh air or condition it if after you're installed you're having indoor air quality challenges. On the downside, they really work best with no fresh air at all. Even small amounts of fresh air can eliminate the need for compressor operation for dehumidification for a significant amount of the year, and if that's done, then you have a machine that can't really do what its benefit is. And if you increase the outside air, it makes it really an expensive, complicated solution that really isn't matched to the duty for a lot of the year. Now, if we talk about outside air, got one more poll question for you. we picked Chicago here, but in Chicago, how many months of the year do you think the ASHRAE 62.1 minimum outside air would dehumidify a typical public pool? We gave you a range of months here. So how many months do you think that it would do that in Chicago? Okay, so the response was 0 to 3, 4 to 6, 7 to 9, 10 to 12. And 0 to 3, by the way, is way too low. It tends to be around 6 to 7, actually, that the minimum outside air will do it, sometimes as much as 8. So 10 to 12, no, that was too optimistic, but it actually falls in the middle of the two middle ranges. If you took that same pool and put it in Atlanta, what would your answer be? Everyone went 0 to 3. It's actually 4 to 6. And it's actually probably closer to 6 than it is to 4. And I know that that's a little bit surprising to people, which is one of the reasons we wanted to ask that question. So in the version of outside air for dehumidification, you're going to bring the outside air and dehumidify it with the naturally dry outdoor air rather than use compressors. Very often you're going to have an air-to-air heat exchanger in there for energy efficiency because you're using a fair amount of ventilation air. So the little schematic here is actually the 100% outside air version. However, 100% outside air isn't really a great idea. If you don't control the volume of the outside air, as we mentioned earlier, your RH in your space is going to go way, way too low in the wintertime. So the bottom schematic is the one that is more often done, and that's modulating outside air from whatever the minimum is set for IAQ in the air quality, and then modulate it up from there. So the operation of that type of a system says, well, we're going to bring a portion of the outside air in and then have that go through the air-to-air heat exchanger. The outside air is preconditioned by that, and then the amount is going to modulate upward as you come into the shoulder season, spring and fall and summer, where the minimum outside air is no longer doing the dehumidification. End up mixing the dry outside air with return air and then deliver that to the space. And typically the exhaust fan modulates on pressure to control your space pressure at a slight negative. The pros of that system are its simplicity. You're going to end up with a more healthy space because you're bringing in more fresh air. It's relatively energy efficient on the ventilation side to do that with an efficient heat exchanger. Has a lot of flexibility on the evaporation rate. Again, go back to my 40-ton idea. If that system was sized for that and it turned out to be higher, in this case you could modulate the outside air up a little bit and you'd be fine. And so for the majority of the year you'd very easily adapt to that. The cons of the system we're showing here is that you can't control summer humidity in most climates with this, because at some point the outside air becomes too humid to do it. And it's usually around a 63 to 64 degree dew point outside, by the way. You don't have to get all the way to the dew point of the space before 100% fresh air won't do the job. So the downside really is we're not addressing pool water heating. With that type of a system, you heat pool water separately with as efficient pool water heater as you can. It can also be a pro, however, because it simplifies the refrigeration system quite a bit. It simplifies the operation and the controls, and so it tends to result in more reliable systems that don't cost as much to put in. There is an answer, however, and this is what we've worked out through the years to using the outside air, but not going all the way to 100%, and also adding a cooling coil to handle the summer dehumidification so that you have a year-round solution. And that solution uses a de-exert chill water coil within the system, and now you can control year-round. And I'll go into a few details in a sec. And so kind of optimizing that hybrid concept, you would modulate the outside air from the IAQ minimum up to typically around 40 to 60% of the supply air, not 100%, to control the humidity for more months during the year. Typically, compared to the ASHRAE minimum, using this concept, you can get 2 to 4 more months of energy efficient dehumidification by modulating that outside air up. Introducing more than the minimum makes the space healthier while you're doing that. So as a side benefit to the efficient dehumidification, you're also getting more fresh air to the space. Tends to result in lower operating costs than dehumidifying the pool airstream if you dehumidify the fresh airstream. So if you'll notice on this diagram, cooling coil is in the outside air after the air-to-air heat exchanger. And what you get is that, let's say for 3 months we need to use the dehumidification, the chilled water or DX. Typically 2 out of those 3 months, and sometimes even more, the outside air has less energy in it than the pool air does. And so even though we're using mechanical dehumidification in those months, we're saving energy by having to use less DX cooling to achieve the concept because the enthalpy of the outside air is lower. This system doesn't care whether you have a DX or chilled water coil, really. It works the same way since we're not trying to heat pool water. So if you have a large university or institution that has a central plant, this system is essentially as effective with the exception of not recovering hot gas reheat energy. And it also, interestingly, has a very, very high dehumidification efficiency when you have a high wet bulb day. So if you have an 88, 78 day, the dehumidification efficiency on this is about 60%, where dehumidifying a pool and airstream, you're typically down more like 45 to 50%. So it's extremely effective at doing it. So when you use this hybrid idea, your compressors are only running in the warmest, most humid months. I've got a few locations here, how much compressor operation you need. And in Chicago, it's really only 1 to 2 months of the year, 3 to 4 in Atlanta. You can see DC. In an arid climate, mountainous climate like Denver, 50% fresh air will dehumidify to the design dew point day out there. So you don't even need to use it for anything other than space cooling. It's also a kind of a nice thing for maintenance rather than servicing refrigeration systems on the roof in the wintertime. I know we're in Minnesota, it's cold, you put a unit on the roof, and that was one of the major complaints about mechanical dehumidifiers here locally was the techs were not very comfortable if they had a problem that happened in the wintertime. So then I'd like to talk about the ventilation itself, indoor pool and outside air, and really how much outside air you should provide. If we go back to the original slide and we say, well, 0% obviously was not a good idea. 100% created conditions they didn't like and was very energy wasteful. You don't want that. So what is the right amount of air when you're designing an indoor pool space? So ASHRAE has some good guidance on that. ASHRAE provides guidance on indoor pools through standard 62.1 and also the ASHRAE applications handbook. And there's a lot of good information in the handbook about designing all the things associated with pool spaces. So ASHRAE 62.1 prescribes amounts of outside air. The handbook states that the amount in 62.1 is intended to provide acceptable air quality for an average pool using chlorine for primary disinfection. There's a table in there that specifies people and area rates for different places. In the case of the pools, is strictly an area rate, and basically what it's telling you is to the breathing zone, which is 6 feet above the floor, you need to get 0.48 CFM of square foot of pool and deck area. And then if you have a spectator space, that falls under a different occupancy category, and you have to have 7.5 CFM per spectator. And that's only when that area is occupied that needs to happen. It's worth noting that there's not a people component to that. Most other spaces in 62.1 have both a base area component and then a component for people. But in the case of the pool, it's really only the pool surface and the deck area that's used in the calculation, and the people component, it's really for indoor air quality for chloramine removal. Another note to make there is over the years there's been a lot of discussion whether it's dry deck or wet deck, because the deck area that is dry obviously isn't off-gassing chloramine. And so it's up to the engineer to do it. The most recent version of the standard basically says that the engineer needs to determine the area that could possibly be wetted during occupied operation. You can play with those numbers in different ways, but the safest way to do it is to assume the pool and deck area is all used in that calculation. An exception might be a hotel where you had a seating area in the same space. So it talks about the minimum rates in the breathing zone, and it typically is going to result in about 15% outside air if you design on 6 air changes of air movement, which is common. If you have a 30-foot high space, common, and you use all the pool deck area in that calculation. If you designate some as dry deck, it could get a little bit lower. So what is the effect of that on the pool, the ASHRAE minimum outside air? Well, if we had a fixed 15% minimum, mechanical refrigeration system is going to have good humidity control. Not quite as good as if you had no outside air, because now you're starting to affect the conditions a little bit. Energy consumption goes from low to medium because now the outside air reduces the need for compressors. As we said, anywhere from 5 to 7 months, 8 months, depending on where you are climate-wise. And it makes the DX system low, not at full load and less efficient. As far as chloramine removal, it's limited to what you can get with ASHRAE 62. Typically requires ideal air distribution and really excellent water treatment. The comfort temperature control should be good. If you look over to the outside air concept, starting at a 15% minimum and modulating up to 100%, you get, humidity control would be good in the winter now, but in the summer, unless you did the hybrid unit, you're not going to control it in the summer. Your energy consumption would go low, other than the fact that you weren't controlling the energy in the summer. Chloramine removal would be limited at the low end, but excellent when you modulate it up. Temperature control would be good. So that's kind of the effect of using ASHRAE minimum outside air on those two styles of systems. But one of the major issues is that the amounts in the table don't take into account some pretty important factors. One of those is the height of the space. The table doesn't care whether the space is 6 feet tall or 50 feet tall. And that's not reality in the pools, because a lot of times you're delivering a fair amount of that air above the breathing zone to spectators, to wash windows, to wash the roof. And so a lot of that outside air is not getting to the breathing zone. And so the air distribution really needs to take that into account. And then you have the activity in the space itself. You get a lot more evaporation and a lot more chloramines moving into the air on a rec pool that has some slides and a mushroom and different water features than you do in a hotel pool with just a little bit of swimming. And the ASHRAE 62 doesn't really take that into account, but it probably should. And in fact, the handbook notes that, basically saying that the amount from the table may not be adequate for high occupancy public pools. We've definitely found that to be the case, and I haven't yet met someone that's designing a pool that doesn't intend for it to be high occupancy. Others have experienced the same thing. There's a quote here from the aquatics director at Penn State University, and which you can read, but the gist of it is if you're using a recirculating type system, you're not getting rid of the chloramines, and if the air handling system doesn't significantly exceed the existing ASHRAE standards, then a heavily used pool will probably have an air quality problem. So that really has been the case that we have seen in our experience, both retrofitting systems and in supplying our own and figuring out where the outside air needs to be. So how much really should you have in practice for good indoor air quality? We recommend that you do the larger of the ASHRAE 62 tabled amount, or 25% of the outside air based on 6 air changes. It results in about 50% more fresh air than the table value for a lot of public pools. So instead of the 15%-ish, we're going to be at that 25% number. And the reason we recommend that is because we found it works. It works very well. It works with various air distribution, and that's one of the key things. I mentioned up front that water treatment is important and air distribution is important, but a system that is using fresh air provides a lot more flexibility and covers up a few sins so that you may not have to be absolutely perfect on those other things for your system to work. And so, it's a more real world type of system in my view. So the pros of that certainly are it's going to remove more chloramines. That should help the pool chemicals work better, eliminate that pool smell, and help reduce the corrosion. Certainly healthier for the occupants. When people get in there, they feel good in the pool space, which has certainly not always been the case. And it's low-cost, simple dehumidification throughout most of the country for most of the year. Increasing the minimum outside air is going to control the humidity at a big economic benefit, and you're not going to need to run the compressors. In this case, instead of the 3 to 4, 4 to 5, 5 to 6 month type thing, we're adding a couple months to that, just at the minimum. The downsides are certainly that, okay, you're increasing the ventilation load a little bit, but you can certainly impact that with using an efficient air-to-air heat exchanger. We're big proponents of the flat plate because it's a 70% efficient device. You can use a heat pipe or runaround in something, and they're better than not doing it at all, but typically they're 45 to 50%, so they're not capturing, they're not maximizing what you could get. Even at 25% outside air, you could reduce the space humidity below 40% at night in cold climates, and that's not desirable. Your evaporates are going up, and your pool water heating then is going up. But you can do some relatively simple things in an occupied mode to reduce or eliminate that and keep that in the 40 to 60% range that is recommended in the applications guide, because your evaporation is going down, you have a still pool, your chloramine production is going down, and you can justify reducing your outside air to some extent. So then looking at if you increase that minimum outside air in order to handle your indoor air quality, what does that do to the dehumidification equipment that we've been talking about? Well, in the case of the mechanical dehumidifier fixed at 25%, the humidity control is still pretty good, although the systems that try to use a heat pump could drive the RH pretty low in the winter. Your energy consumption is now going medium to high because you don't really need the compressors now. You're not going to get nearly as much reclaim possibility, only really a few months in the summertime, and it makes that DX system even less efficient. So it really isn't a very good system when you don't need to run your compressors. The job of chlorine removal now, because we're getting more fresh air to the space, and the comfort would still be fine. The outside air, if we talk about the hybrid system, really then we're going to modulate from 25% to whatever the max outside air setting is, 40 to 60%. Typically, your humidity control is good. Your energy consumption is quite low, and you're doing energy recovery. When done correctly, you're going to be doing energy recovery on all of the fresh air you're bringing in, so you can keep the increased outside air impact down. Your chlorine removal is great. It's set for minimum outside air, and then when you do modulate up for that efficient dehumidification, you do even better, and the comfort, again, is good. So it really doesn't have a major effect on the outdoor air system because it was designed for it. So when you look at the two different solutions we've been talking about, the outside air unit, all you get is a small increase in the ventilation load you can offset with your heat exchanger. I kind of joke it's kryptonite to a mechanical dehumidifier, increasing the outside air for indoor air quality, because then they're really just an expensive, complex system that's truly misapplied to the loads that you're experiencing for basically everything but summer. So it's really just the wrong system to be considering if you're going to do more indoor air or more outside air. And to the point that this particular discussion has not been about energy, but if you look at operating cost comparisons for a sort of typical pool, this is a competition pool in various environments using the optimized outside air idea, the hybrid version of that versus a mechanical dehumidification system, you're going to see operating cost savings in the ranges that I've got up here for the various locations, kind of coming from south to north and humid to less humid. But and things can kind of affect this. These is sort of standard energy usages between gas and electric, and you have a lot of things that go into it. But this is a fairly straightforward comparison for the same system. And really, if you use outside air effectively and not just say I'm just ventilating, or compare it to just using mechanical dehumidification, then the outside air can really put you in a sweet spot where you can get really good control of your environment at very good operating costs. So if I go back to the sort of design challenge that I mentioned when we got into the market, using this optimized solution controls the humidity all year round, so that should control the corrosion. We're getting typically 50 to 70% more fresh air. In some cases, it's even higher than that if they were using a lower percentage to start. So a lot more outside air to the space. The system has an active pressure control that moves with the change in ventilation air, and that works very well. I've sat in mechanical rooms and watched that happen, and that way you keep control of the pool chemicals and humidity. It can help remove the chloramines from over the pool with, again, that's an air distribution thing as well, but you're providing more fresh air, more exhaust air. And by doing that, you help the water treatment work. And then, again, it's a very simple system versus those more complex DX systems. So we really, the system really handles a lot of those questions that we looked at when we got into the market. So that is really what I have today for the main presentation, and I guess the floor is open for for questions. I'll turn it to Scott to poll the questions and let me know what people are interested in.
Thanks, Gary. We do have a lot of good questions from the audience, so we'll jump right in. Our first question is, how does the use of a cover affect your considerations?
Oh, a pool cover. If you can use an effective pool cover, then at night you would save on your dehumidification and on your need for ventilation air. So should you be able to use one and it can effectively cover the pool, then you really should be able to go to an unoccupied mode, which would take outside air down to a very low level, maybe even get rid of it if the pool cover does a great job of covering the whole thing. Your system then would be seeing no real loads from the pool. There are some issues that pool covers create with trapping chemicals underneath, and you might have to do a little purge operation at the start to clear away whatever it's covered up. We don't tend to see a lot of them. I think maybe pools aren't rectangular, and it is sometimes a challenge to find a place to efficiently store them and deploy them. But I have seen them in pools, and they can be a effective way of controlling energy costs during unoccupied modes.
What about using heat wheels instead of fixed plate?
Well, a lot of times you're trying to dehumidify at a point when the heat wheel would be humidifying. There's a theoretical argument that could say you might want to use it in the real coldest days in winter to avoid that low humidity thing I talked about. And you might be able to use them on days when the outside air is more humid than this pool space. But remember, the pool space is 85 and 70 degree dew point or something like that, so there aren't many hours. And then you get into the issues of swimming pools, of heat wheels, and how reliable they're going to be in that corrosive atmosphere. So far, we've really mainly replaced them, frankly. They aren't done very often, but again, mainly it's because the large bulk of the hours that you would want to use a heat wheel, at least an enthalpy wheel, they're doing something that you don't want them to do. In the case of a sensible heat wheel, I definitely don't advise them. They would have the ability to move moisture because they condense on them. They'll move moisture over in the outside airstream when you don't want it to, and realistically, you don't need to bring that mechanical complexity in when you can get really good recovery from a different type of energy recovery. So I would never recommend that.
What should the exhaust rate of a pool be? What percentage negative is preferred?
So ASHRAE says 5/100ths to 0.15/100ths inches of water gauge. And we found that the low end of that is preferable. If you start getting up to those higher ends, you won't be able to open your doors very well. Innovent sets our systems at 0.04, and we found that works. But it isn't a simple answer because you don't know how tight the pool space is going to be. A well-built one that has doors on openings and stuff might only be a couple percent. But one that has more openings or isn't as tight as you'd like, we've seen them over 10% of supplier volume. And so at that point, trying to maintain a 4/100ths negative can be really challenging. But long answer to a short question, typically right around 4/100ths tends to be where the system works well to maintain negative and allow the doors to open well.
If you were to monitor indoor air quality with a building automation system, what would you monitor for the best indoor air quality?
That's the biggest challenge that's out there probably. I would say that you probably want to it's hard to monitor with a building automation system is the short answer. Really, the best thing right out now is the smell. Are you smelling chloramines or are you not? There are some people promoting the use of a VOC sensor for that purpose. Unfortunately, chloramines are not VOCs, so I find that to be a little bit frightening. It may turn out in time that that can be okay, but you're trying to measure something that with a sensor that isn't intended to measure that. CO2 doesn't work because CO2 is measuring people in the space. You could use that in a spectator area to give you an indication of how many people were there. So I guess right now with a BAS system, I think there isn't an easy way to try to monitor indoor air quality. It has to be more the operator and, you know, what he feels, whether he feels like he has control of the smell and whether his pool chemistry is remaining in control.
Do you suggest reducing outside air to the minimum during summer and then just use the maximum 50% during winter?
No, it's actually the flip side of that. And people ask that question with good reason. So in winter, you're going to run the lowest you can for indoor air quality because otherwise you'll dry the space out too much. In summer, with that hybrid solution, it stays at 50%, and there are typically a very small number of hours during the year where the outside air enthalpy is high enough that you could argue from an energy standpoint you could save some money by going back to minimum, but that would also likely cause you to put the cooling coil back in the return airstream, put a bypass damper over the top, maybe add some other dampers, make the system more complicated, and you'd be chasing a few energy dollars in order to, you know, make the system a lot more complicated than it needs to be. And the other part of that is the thing I mentioned about the high wet bulb days and the really efficient dehumidification you get by dehumidifying outside air. You know, in a lot of the humid part of the country, continental climates, whether it's Minneapolis or whether it's Nashville, the wet bulb design conditions are actually pretty similar. They're all 88, 78, 87, 77, 89, 88, or 78. And if you run that across an outside air, you know, the 50% idea that we're talking about across the cooling coil, you'll do so much more dehumidification with that it's actually worth running it through there. So again, maybe a little bit of a long answer, and it's possible we could save a few BTUs doing it the other way, but it makes the systems, again, it goes back to making the system very complex.
In cold climates, your hybrid system may need defrost periodically, correct? And how do you deal with that?
What we've seen in our systems is right around 0 degrees outside, you're typically going to require some defrost. Our standard system is a phase bypass system that you use on the air-to-air heat exchanger. In very, very cold climates, a lot of times we'll recommend using a preheat if you can do that to get the air heated up to about that 0 degree range, mainly because of reliability. If you have a defrost system fail in a office space, not that big a deal. You know, it gets uncomfortable. If you have something fail in a pool space, you start condensing all over the inside of the pool space really quickly. So it is a consideration. It's interestingly, in a way, not as challenging a defrost situation as you have in a space that's only got a 40 degree dew point, because it's so humid with 60 some degree dew point that it takes a lot of energy to get to the point where you're in a defrost situation. But once you're there, then you have a lot of condensate to deal with. So yeah, we do defrost at the very extremes, some preheat, more typically just phase bypass. Some people handle that. If you do a runaround system, they'll just have glycol in their system year-round, and that can work, although then you're affecting your system all the time with the glycol. So our preference is to do it the way I've described.
How does the size of a hybrid unit compare to that of an older DX-type unit?
Most often the lengths are similar. Most often the widths are similar. And that hybrid unit, because it is doing two air streams, normally is stacked, and if they're stacked, then it's usually a little bit taller. We've been pretty successful being able to retrofit those types of systems, but depending on where they're at, and the hybrid system doesn't really work in Motel 6 pools, so because we don't fit in the pool mechanical room. So in that case, we're not really getting involved. But most often, unless we do a side-by-side with the Airstreams, in which case we might be a little wider, and then we can meet the height. So they're not exact replacements, but they usually can work.
What type of corrosion control on plates is recommended in coastal zones?
Okay, so coastal zones is perhaps, let me back up one. We don't recommend coating our air-to-air heat exchanger at all. It's pure aluminum. Aluminum is proven to be by far the best material in that application. We've never had one fail ever. So in general, we wouldn't do it at all. In a coastal application, there isn't any consistency in our custom air handling stuff to what people want with that. Some people use aluminum on outside air systems. Some people want to coat things with phenolic or epoxy or various things. We can provide the air-to-air heat exchanger with an epoxy coating. Again, to me, it's not necessary in most applications. We have done coastal ones. I've never seen a problem with them. So I guess my initial reaction after talking that through to myself would say, I don't think you need to have one on the air-to-air heat exchanger.
We have time for a couple more questions. Where should return intakes be in a pool space?
Ideally, I think from an air distribution situation, you want to have both low and high. You want to have some low ones to induce some flow across the pool to clear chloramines from the water. You'd like to have high as well because you need to generate good mixing. If you have dead spots up top, you're going to have corrosion. So the ideal situation to me would be to have some low and some high, and the percentage might be 60-40 or 40-60 or whatever, depending on what the needs were for the distribution up high.
Can the outside air be shut off during unoccupied times?
I would, unless you had that pool cover, I would say absolutely not. In fact, I think that's one of the more foolish things you could possibly do. The evaporation isn't stopping, the off-gassing of the chemicals isn't stopping, and you can ruin your space quickly, and you can ruin your air handler quickly by doing that. So I think that that's a practice that should be completely avoided unless you have a pool cover.
How does air distribution factor into the dehumidification of an indoor pool space?
Well, as I mentioned about the mixing, you need to have that, and I also talked about the microzones. So from the standpoint of getting the outside air delivered where it needs to go for the dehumidification as well, and then getting the air distributed in a homogeneous manner so that you can control the humidity from getting too high or too low in areas. It's certainly a factor. I mentioned that air distribution is important. Air distribution is very important. We have some stuff on our website that discusses that, and like you said, ASHRAE in their applications guide has some good things about it as well.
All right, we have time for one more question. Can an outdoor air dehumidifier with a supplemental refrigeration system provide pool water heat?
Sure. If you want to put pool water heat on it, you can. What we would typically say is unless you're in climate zone 2 where you've got 6 months of running it, it's not going to pay back. And so the complexity, first cost, making that refrigeration system more complicated isn't justified. Typically climate zone 3 and above, the payback will be really long and you'll just be asking for more problems. But you can add it to systems if you want to, because it's just another condenser.
I'm afraid that's all the time that we have. I'm sorry, Gary, did you have more to say?
No, that's okay.
Okay.
Probably would have gone into a larger topic.
Okay. Well, I'm afraid that's all the time that we have. On behalf of HPAC Engineering, I'd like to thank our sponsor, Innovent, for making today's event possible, Gary for sharing his expertise, and all of you for attending. Take care.